Okay, so basically we're going to talk a little bit about the different parts of a program. So what I'm going to put up here on the board, think of it as different classes in the same application, the same Java application. Now this is going to be pseudocode. I don't expect this to actually compile, but I think it'll illustrate some stuff nicely for you. Let me get a few windows created here that will represent my different layers. So I'm going to, this first one, let's say class main and public static void main, you know, yeah, it's got arguments and stuff. And we'll come back and we'll do some stuff here with all of the things that we're creating. Okay, down here at the bottom layer, we might have a database object in our application at some point. Now, you know, we're not writing programs that are reading persistent data from someplace like a file or a database yet. We're not writing data to a file or a database or anything like that yet. So think of this conceptually right now to illustrate the point that I'm trying to make. But everybody knows what a database is and what this represents. So hopefully it won't be confusing as I go through it. So, you know, any reasonable database type object I guess I hit a key that caused all my windows to minimize, but okay. Okay, let's just leave that at where it is right now. So assuming we've got this database object and we can pass it a key and it will read a record from the database that matches that key and it'll return it to us. Or I can pass it a record and it'll store it for us. We might even have a key parameter that I pass it and the record that I want to write. But, you know, in most of our object-oriented systems, the key is part of the record. You wouldn't have anything that's part of the key that's not part of the record typically. And so you wouldn't necessarily have to pass it. But just to be overly descriptive, I'll go ahead and make that a parameter here. We don't know how this database is going to connect to an actual database server. That's immaterial. Just know that it's able to if it needs to. So that's it for now. Over here on the main function, we're going to probably let's say, and I think I've been pointing out to folks that that we really only want to do the reading and writing in the main function. We're going to consider that our client interface. And, you know, if this is a command line console application, you're going to be asking the user to type some stuff in and hit enter. And if you want to tell them anything back, you're going to do print lines. That's pretty typical. So then we've got the stuff that in this class we've been trying to implement. and the customer has getters and setters. So this would be a getter. And to have a getter, a public field, a property, whatever of a class, we need to have a variable behind it. So to me, that all of those lines of code right there, that implements the property called name of this class. It's an internal variable, a data member of the class. It's a getter, so I can get the value, and it's a setter that can set the value. Now, I wouldn't typically be doing this for other methods inside the class, primarily to be able to use these. This is for, these objects. So over here in my main function, I might want to say I created a new customer. I get some user input. And I call the setter. Now c.name equals whatever the user typed in. So I did I created the object and I set it to a value from what the user entered. Then later down here, I might want to output something. So I'm going to say, instead of str, I'll print the customer's name. So that would kind of be the whole round trip for it. And then to tie in the database, I'll create a database object, which is the one over there on the right, and I'll store my record. Now, I don't have a record yet. How do I get a record? Don't know. But somehow I have a customer and I need to create a record. So I might have another class and we haven't really talked about the implements thing yet. It was one of the things I was going to talk about today. But, I'm creating this customer record thing. And oddly enough, it's probably going to have the same getter and setter. This is a customer object, and this is a customer record. And I might have a public constructor that takes a customer as a parameter. Well, how do I initialize a customer record from a customer? I'd say this dot name equals c dot name. Okay, so over here, I can create my database object. From my customer object. And then I can say, store the customer record. And the obvious question that I asked my bosses when I first started working on projects like this is, why do I need a customer object and a customer record object? Anybody got a thought about that? Why I would duplicate this so blatantly in my program? Why couldn't I just make my class over here take an actual customer object? You think of any reason why this would be good? Pro and con? Brainstorming? A lot of this gets subjective, so I mean, there's not any real right or wrong answer, but there is an answer. It goes back to, when we start talking about architecting applications, we talk about good architecture involves loose coupling and analyzing the cohesion between objects and between different components inside software systems. And if I was to if I was to make the database object dependent on the customer and the user interface dependent on the customer, if the user interface required me to change something instead of getting name, let's say the user interface, they decided for usability, they want to ask the user for their last name and first name and middle initial, and they want to concatenate those together in a prescribed way and set that as the name. Well, then the program managers or the architects or the programmers writing this software might take this name variable and split it up into 3 variables: first name, last name, and middle initial. So now we've got 3 of them. Well, now I've just broken the database object because it won't compile anymore. It was written to get customer.name, and now name doesn't exist anymore. And now I've got 3 new properties: first name, last name, and middle initial. So the tight coupling between database and customer would cause the architecture to be brittle. And brittle means prone to stopping all development while one simple new feature request causes a ripple effect across many, many parts of the system. Whereas if I develop it loosely coupled, if I have a customer record that the database is dependent on and a customer object that the user interface is dependent on, then I can make extensive or minor changes to the customer object that the database is not dependent upon. Okay? If I add a first name, last name, middle initial to this, all I really need to do is say, I'm going to create this customer record. And see, this is even too tightly coupled. I don't want to pass a customer record. I want to pass a name. There's no reason the customer record needs to know that there's a customer class at all, that it even exists. right? This, I don't want this to break if the customer object gets modified. This is now even more loosely coupled. So then over here, I can create my custom object from c.getName. And then if I change and I make this first name, last name, and middle initial, then all I have to do is change this parameter here. So I've restricted that change to these two classes. The customer record class and the database class are completely unaffected by that change. And that's why we want to do this. But I really wasn't wanting to get into loose and tight coupling. Like I remember one time on my resume when it said, you know, sort of like, what is your career goal? Because I want to be a part of a team that designs and architects loosely coupled systems. Why? Because I've been a part of too many teams that design tightly coupled systems that are extremely brittle, which indicates a high level of technical debt, which means I'm going to spend all my time fixing bugs. I don't want to fix bugs. I want to implement new features. I want to have fun. I want to design. I want to be creative. I don't want to sit there and track down, oh, okay, you guys changed this and now this doesn't compile anymore and I got to go fix it, right? That's boring. It's tedious. It's mind-numbing. So what feels like a lot of duplication, a lot of doing the same thing over and over and over again, is for a purpose. It does benefit you when you get a little bit of experience under your belt and you realize, oh, yeah, I just made that really easy on myself when I did that. And this is just one example. But typically you will have an object that faces this way and an object that looks very similar that faces this way towards the database. Okay, that's just a pattern. You may even have internal ones, because if you have a client server and client server architecture, you know, an n-tiered application, then your client's going to be passing an object to this layer. That layer is going to be mangling it and passing it to the next layer, which is going to be mangling it and passing it to the next layer, which will be mangling it and sending it to the database. So you may have the same or relatively the same customer object implemented in several different places in your system, in your application stack, and you might have to go track down all these objects. But the idea is that if you're maintaining this one layer inside your architecture, you really don't often have to go outside of that to go making changes in other people's layers. You've got, you know, tight ownership and few dependencies. So loose couple and appropriate amount of cohesion between layers. And you can't have no coupling, right? You just want to minimize it to contracts. It's like, you know, your plumber and electrician, your roofer, they don't all live with you. You don't have to give each one of them a bedroom in your apartment, right? You write a contract with them, they come and they deliver services in return for, you know, money that you give them, and then they go away, right? They come, they do their job, you don't even have to watch them, you don't know how they did their job, you don't know what tools they used. As long as when you're done, you can observe that they did what they're supposed to do, and that's very similar to this. As long as this database object reads and writes the data to and from the database, do I care how it makes a connection? I don't care. Do I care what kind of database it is? No. As long as I give it my record, and then later when I need the record back, it gives it back to me, great. You're fulfilling your contract. Does that make sense? And Fredley, does that help sort of explain what's going on here with these getters and setters? Yeah, so when I'm doing the set name in here, I don't say, you know, I don't need to do that. I've already got the name. You know, they passed it to me. Or if they call me and they say, hey, can you please return me the name? I don't say, you know, I don't read data from the keyboard right then and return it to them. No, I've already got a property called name, or a variable called name. I just return it to them. That's the whole job of this object, is just to be the representative or representation of that customer data. And so the project that you guys are working on, the Is Good Day, you know, the Good Day class, is the same thing. It just sits here in the middle. It has a bunch of variables. It has a bunch of getters. It has a bunch of setters. And that's all it does. It doesn't read data from the screen. It doesn't do prints. It just sits there and represents that class. The main function is the one that says, create a new instance of the object, get the data from the customer, call the setter to save this in this instance of this object, do a bunch of other stuff, and then eventually come back and get the value out of that object again and print it on the screen if it wants to, or store it in the database if it wants to. But all of the logic and operations and interaction with the user and the database and all this kind of stuff, that's all happening here in the main. And these guys are just, you can think of them as helper object classes, but that's all they're doing. They're data classes. Make sense? Does that help anybody, I hope? Okay.